Okay, guys, we're going to look at the examples in the section on antiderivatives. So hopefully you've printed out your notes that I told you to print out, and we will work through these examples. So make sure you read through the notes, because I gave you, the different rules that you'll need to know. I gave you, how to integrate a constant, how to do that basic power rule, and then those trig derivatives. All right, so we're looking at the first one, and we're finding the indefinite integrals, and the first one is the integral of 6x cubed dx. So I'm going to use a basic power rule on this, so I like to copy mine underneath. And the basic power rule says you add 1 to the exponent, and you divide by that new power. So you want to make sure that you reduce that fraction to 3/2, and it's x to the 4th. And we talked in the notes, and if you'll read it, we talked about putting that plus c on there to stand for, there might have been some constant there. It stands for that arbitrary constant. And so that's just it, the basic power rule. Add 1 to the exponent, divide by the new power. Now, if you thought about it, if you wanted to check your answer, you look at, all right, let me see, if I take the derivative of 3/2 x to the 4th, I should get right back to my original problem. So when I do 4 times 3/2, I do get my 6, and then I drop it by 1. And so I know that I did it right, because that's what it is up there. So basic power rule. All right, let's integrate this one. So I've got the integral of 8x to the 9th minus 3x to the 6th plus 12. So again, I'm going to come underneath and give myself some room. All right, so power rule. Add 1 to the exponent, divide by the new power. Add 1 to it, divide by the new power. When you have to integrate just a number, when you have to integrate a constant, all you're going to do is put that variable on there. And since I'm in dx, I'm going to put that x on there. So if I reduce it, I get 4/5 x to the 10th minus 3/7 x to the 7th plus 12x. And again, I'm going to put my plus c on there to stand for, there may or may not have been some constant out there. If you want to check it, remember, just do the derivative. All right. So then I gave you a note. Make sure to rewrite all radicals as rational exponents, and bring all variables up from the denominator whenever possible. And also it says to make sure you rewrite any negative exponents in your final answer. Don't leave those. So when I look at this one, I know it's not super clear, but that's the cube root of x plus 2 sine x. So cube root of x, we're going to rewrite that as x to the 1/3 power. All right, so now what I don't want to do is when I add 1 to it is do this. Because it's that fraction, go ahead and put it in its fraction form. So instead of adding 1, I'm going to go ahead and add 3/3. So it's easier to add. So I get 4/3. And again, I don't want to do this because that looks ugly. All right, think about algebra. Dividing by 4/3 is the same as multiplying by 3/4. Go ahead and write it like that. And then trig, I'm going to integrate in a completely different way. So I have to think about whose derivative would be sine, and you know that the derivative of cosine is negative sine. So when we go backwards, we're going to need that. So that's going to integrate as 2, and the sine would be the negative cosine is its integral. So I get 3/4 x to the 4/3 minus 2 cosine x plus c. So moving on, we'll do this one the same way. I'm going to stretch it out, write it a little bit bigger. I've got 4x to the 3/5 minus 7x to the 2/3 plus, all right, let's think about this one. If I bring that square root of x, we know the square root of x can be rewritten as x to the 1/2. And if I bring it up, it'll be a negative 1/2. All right, so I'm going to add 1 to it. I'm going to go ahead and put 5/5. My new power would be 8/5, and dividing by 8/5 is the same as multiplying by 5/8. Same thing here, add 1 to it, so I'm going to put plus 3/3. I always match that denominator, and I get 5/3, and dividing by 5/3 is the same as multiplying by 3/5. And add 1 to it, so I'm plus 2/2, and I get 1/2, and dividing by 1/2 is the same as multiplying by 2. All right, if I put it all together, I cancel out, I get 5/2 x to the 8/5 minus 21/5 x to the 5/3 plus 12 x to the 1/2 plus c. If you want to go back and fix that, x to the 1/2 is the square root of x, you can, but it's not necessary. All right, now, when I look at this one, when I look at E, when there's just one term on the bottom, okay, you want to divide it out. You want to simplify it algebraically first. So if I divide it out, if I divided everybody on the top by x to the fourth, I get 1 minus 3x to the negative 2. Remember, you subtract those exponents when you're dividing, plus 5x to the negative 4. Okay, so whenever that one term, we're going to do something different when we have more than one term, but when we just have one term in the bottom, you want to divide it out using your algebra first, and then this is what will integrate. So I'm going to copy it underneath, and here we go. So to integrate just a constant, you are going to put that variable on there, and since it's a dx, I'm going to put that x. All right, here, add 1 to it, divide by the new power, and here, add 1 to it, divide by the new power. All right, so I get 1x, and that's going to be plus 3x to the negative 1 minus 5/3 x to the negative 3. But now we don't want to leave these answers with these negative exponents. We want to make sure that you fix those. So this one would be 3 over x minus 5 over 3x cubed plus c. Rewrite any negative exponents. Don't leave those for me in the answer. Okay. All right, this one, F, is another trig one, so you just need to make sure you have in your rules memorized how to integrate cosecant squared theta, and so it's going to integrate as the integral of cosecant squared is negative cotangent theta. So I get negative 4 cotangent theta plus c. I posted all those trig derivatives in the notes that you're supposed to print out. Make sure you do that. All right, and last two examples. All right, if I look at it, there's no derivative that I have, or integral that I have memorized as sine x over cosine squared x. If you've got something right now that you don't know, you don't have memorized, it's not a rule, you're going to have to think about how to rewrite it. Okay, we'll have many different things that we try, but right now we're just going to try to rewrite it. So if I think about it, I've got sine x times, let's see, I've got 1 over cosine, because I kind of like to spread mine out first and think about what I got. And then I know if I put sine over cosine, that's just tangent. So then that's the integral of tangent. And then 1 over cosine is secant. And I do have a rule that is the integral of secant x, tangent x. I'm going to write it in how I'm used to seeing it. Okay, so the derivative of who is secant x tangent x, and that it would be secant x, or secant x plus c. I was thinking I was in thetas, but these are dx's. All right, and then the last one, and we're doing a little bit different, and I gave you some notes on those initial condition problems when we want to get that particular solution. Okay, so we want to find that particular solution, and whenever you're given this initial condition, it means you want to get rid of that plus c. You want to figure out what it is and not have that. You want to have an actual what number is supposed to go there. All right, so the first thing you're going to do is you're going to integrate. All right, so we're going to integrate that 3x squared minus 1. All right, let's use our power rule. Add 1 to it, divide by the new power. And to integrate that one, I just add that variable x on there. So I end up with x cubed minus x plus c. Now this is equal to f of x. All right. Second thing I want to do is use that, that initial condition. Use that given condition to solve for C. So f of 2, oops, hold on, f of 2 means everywhere I have an x, I'm going to plug in 2. And I know, because it tells me right here, f of 2 is equal to 4. So when I plug in those 2's, I should be equal to 4. So if I can do that algebra out, I get 8 minus 2 plus c equals 4, or 6 plus c equals 4. And so c would be negative 2. So that gives me that the answer is x cubed minus x minus 2. And there is my f of x. All right, so make sure you go and try those problems in that work.